Alright, another draft science video, number 10 I think. Sorry about the computer noise, laptops, electrons, having a heat problem I guess. Anyway, so this Mr. Roboto 2 guy, I was saying his name wrong, getting a little snarky, so I think we got him a little desperate. Yes, we're going to kill his golden unicorn of phantasmagorical nonsense, and he doesn't like it. So anyway, same old stuff. I've already dealt with this 3 times, but with it again. I did have an observation that says, it's a complex subject, but somebody might find it interesting. Realizations. These are all, it's all just so obvious. Anyway, special relativity can't be improved upon because it's already as simple as possible. It is based on just 2 postulates, right? Number 1, the laws of physics have the same form for all inertial observers. So meaning no matter what where you're moving or how you're moving, as long as you're not changing your momentum, the laws of physics are the same. Which doesn't even really mean anything, right? Like, duh. How exactly can you change the laws of physics? So I'd say that's a silly premise in that sense. Because these are all just fantasies. You're just describing circumstances that can't exist anyway. So another way of saying this whole thing is that all interaction is photon on photon. Okay, the only things that interact with each other are things moving the speed of light. So let's just define photons as, they don't have to be the elemental particle, but let's just call them the elemental particle in the sense that anything that's moving the speed of light is got to be pretty much simple, straight line kind of a thing. Okay, even if it's a group of things, they're all doing one thing, and that is moving in a straight line the speed of light. So that's sort of the rule. That's what stuff does, elementally. And what can happen is, like I said, this light gets trapped in spirals in circular momentum, and that is the nature of matter. Once that happens, you've created something material that will now acquire mass, what we claim to be mass. Anyway, all interactions between this mass, which is photons moving in circles, and photons not moving in circles. Photons don't interact with each other much when they're not interacting in circles. They do, but they don't interact much. Anyway, the speed of light in a vacuum has the same constant value for all observers. Well, the speed of light has the same constant value in any medium, whether it's a vacuum or not, okay, because the speed of light is the speed of individual photons, and the only time that changes is when photons interact with bits of matter, and then a new photon is emitted that's moving at the speed of light. So the only time light goes slower than the speed of light is when light is it's not the same photon. Okay, the photon is being absorbed and re-emitted, which slows it down. So anyway, constant value for all observers. Yeah, so the speed of light is constant. So yeah, let's agree it's a constant. So these 2 straightforward postulates, again, have been used though as a ground for creating time dilation. And so it's not in these postulates, but I mean it's in the implications of the postulates. So, and again, it's not time dilation, it's matter slowification. It's changing the metabolism of photons, atoms. It is straightforward to show that only coordinate transformations compatible with these 2 assumptions are Lorentz transformations. So I see they just keep using these these Lorentz transformations written in like 1905 or something. They're just these mathematical crap that is based on these premises that are wrong. First, this premise that matter can move the speed of light. So this is all theoretical. It really doesn't have anything to do with reality. From the Lorentz transformations, everything else follows. Length contraction, so this is an argument that in time dilation it's also contracting matter. As time slows down, the matter also contracts. Time dilation and relativity of simultaneity. So these people are actually contending that simultaneous events can be perceived as non-simultaneous, and therefore they're not simultaneous, because people are in these time-dilated dimensions that are somehow real. Like, you can't use the word real. Like, everything is relative, so therefore reality is relative to a circumstance. Obviously, through my explanation, there's no need for any of this relativity nonsense. There's an absolute physics, and what changes is matter changes as you accelerate it. As you give it inertia, as you give it momentum, the matter changes. The relativistic addition of velocities, the equivalence of mass and energy, etc. Yeah, and all those things are correct, except, like I said, you can do math based on a wrong assumption as long as the variable is correct. So I would say that the variable is correct in the sense that matter will change. I mean, time will, for the matter's metabolism, will change in correlation to what might be called a time dilation, but it is not time that has been dilated, it is matter that has been changed. So we're just changing the name of the variable. The variable is still viable, it's just you've misidentified what the consequence of momentum is. Mass, energy, etc. Special relativity offers step-by-step mathematical derivations of these results, in stark contrast to your vague, qualitative, hand-waving arguments. I don't even know what that doesn't really say anything, right? So you say it's a simple postulate, yet you say it's dependent on complex math. So we'll go to one of these PDFs, and you get the idea pretty quick. They're creating variables called a frame. You know, what's a frame? And you know, it's just the same old kind of canard of math. But you know, right here, assume the speed of light the same in all inertial frames. A clock moving with constant velocity in an inertial frame, I, runs at a constant rate with respect to the synchronized clocks of I which it passes. So they're just basically arguing that the clock still works. The matter, the time, and all this stuff dilates, except clocks still work. No, they don't still work. Yeah. So anyway, I'm just saying that it's a wrong assumption, and this velocities, like I said, are extended to, you know, the speed of light for matter, which is not a possibility. So this is all just, like I said, theoretical. And you know, they have these Newton transformations that are, you know, apparently, I don't know, this is a word from some kind of math. You know, and they're perfectly applicable in all circumstances except these theoretical made-up circumstances of preposterous speeds that can't be sustained by matter anyway. So again, let's go back to my argument that the dilation is being created, the time dilation is just being created because when matter moves, it means that a bunch of particles already moving the speed of light have to now move in a direction besides their circularity. So that means the shape of the circle must change. It must eat space in the direction of the movement. It must eat space. It must gain extra blocks of space in the direction of the movement. So when you move an object, the movement forces an extension of the orbit of the atoms, and by doing so, they go past go. They have to cross more time to get to go. So quite obviously they're slowing down their metabolism. It's a very simple argument. If it was analogized again as a school of fish that had a complex amount of motion, and then you had that school drift in a direction, that means some percentage of this motion has to also incorporate an extension in this direction. So as the fish start to migrate in this direction, that means the fish have to swim wider orbits. So you could sort of understand that the only way this knot could move in a direction and still say all the same patterns, they're still doing all the figure eights, they're still doing all this stuff, the only way they could move and do all that stuff is they'd have to consume more space. They'd have to have wider orbits and consume more time. So the overall movement of the figure eights inside the swarm of fish would slow down. Really, people should be able to understand that, this argument. So there is no relative places in space. It's all absolute, and all velocities are absolute. Let's understand that, okay, so light is moving, right? The speed of light is 180,000 miles a second. And, you know what, the fastest to escape the sun's gravity requires you to move 400 miles a second. So something as heavy as the sun, right, you'd have to go really, really fast, though you can understand that to get from the to break free of the sun's gravity from its surface, okay, that's escape velocity, from its surface, you'd only need to go 400 miles a second. But you can imagine that's an incredibly fast amount of speed you'd need to escape the sun's gravity. And yet it's 400 compared to 180,000 miles a second. So, you know, just to get some sort of relative perspective here, that we see no matter in the real world that we watch going anywhere near these speeds. And even if you quadrupled, or, you know, if you said 40,000 miles a second or 100,000 miles a second, nothing, we as a practical matter know very few things could survive movement in space at those speeds, because they would hit particulates, little tiny atoms, little tiny things floating in space, and be annihilated. It could cause explosive damage. It would shoot right through the object, create all kinds of problems. So it's very hard to maintain those kind of speeds in space. And we can sort of understand that if we made a space... Look, they're sending probes to go do Pluto. They're going to go, I think, 20 miles a second as a relative comparison, something like that. Very fast. And, you know, there's all kinds of practical concern that they're not going to survive the trip because of all the things that they can crash into, minuscule things, and those at those speeds will not make them survivable. So we know these are not speeds that matter sustains. Matter does not sustain speeds anywhere near the speed of light. So we're talking about a tiny percentage of this school of fish having to move in this direction. So it's not like we're cutting the fish in half and saying half of them have to move this way. No, it's 1 in 10,000, 1 in 100. Well, it's not 100,000, but it's 1 in, well, yeah, it's almost 1 in 100,000. 1 in 1,000, let's just say. Okay, yeah, 1 in 1,000 fish that you're obligating to make this movement in the direction of the movement percentage-wise. It's a small percentage, 1/1000th of the dynamic of the matter that is moving to get to just these minor speeds. Anyway, so that takes care of that. Okay, to understand the point here, the overall point, which is that movement has a consequence, and the consequence isn't that it dilates space. The consequence is that it affects the matter. The matter itself must consume more space. And so in the circumstance of gravity, what's often brought up are satellites. Well, I'll draw a bigger picture, right? So this is the Earth, and here we have one of these GPS satellites, right? And so they're doing two things, these satellites. They're moving, okay, so that's causing them to be in one of these, you know, relativistic circumstances in one of these relativistic frames of inertia. So they have their inertia and their velocity, and then they have the effects of gravity, right? But they have gravity further from the Earth's center than the clocks on Earth. So you have two clocks. You're going to have to synchronize everything here. So you have this movement, and then you have the movement created by gravity. Now although this thing doesn't fall to Earth, it is understood that this effect is happening. So as something orbits the Earth, it's kind of thought of as a free falling. It's always free falling towards Earth, even though it never falls. Well, the same is true of the thing on Earth. We are free falling right now. You just don't know it because you're being stopped. But the effects of gravity are running right through you, and the force is in your mass being reflected on the ground. You're always going to be creating a force on the ground. If you jump in the air, even just a little bit, you can hear that, you can see the visible signs of the force, but the force is there even when you're not apparently moving. You're applying force, friction force, to the Earth. You're compressing the matter beneath you, and that's a force. So you actually are accelerating. From your body's perspective, you are in motion from the atom's point of view. From the molecular function of your body, you are in motion as if you were doing, I think it's 16, that's 9. It's 9 feet per second, or 16 feet. I forgot how much gravity is on the surface. Well, let's just say it's 9 feet per second. I think it's 16. Well, let's say it's 16 feet per second is the addition of speed. So every second, if you were free falling in a vacuum, you would gain 16 more feet per second into your speed. So if you were going 50 feet per second, it would be 56 feet per second after the next second. And then it would be 60, 72 or whatever it is. You do the math. You add 16 every second to your speed. So you go faster and faster and faster as you get closer to the center of the Earth. So that's because we can't gain any speed, because we are stuck, we're hitting the ground, we still have, from the atom's point of view, from the interior point of view of your body, the atoms themselves are thinking they're going 16 feet per second. So they have the initial energy without any added momentum. So they have no extra momentum to add to that speed, but they have the gravitational speed of what would be the additional speed per second. So from that perspective, you're already moving towards the center of the Earth, and if you were a clock, your atomic structure would be counting time based on that inertia. You have inertia because you're on Earth, and the gravity is creating inertia in you, even though you're not moving. It's as if you were moving. There would be no difference in the interior structure of your atoms if I pushed you in space at 16 feet a second, or if you stood on Earth. The effect of to your atoms is exactly the same in terms of they're going to keep trying to eat this space. So right now my atoms are trying to eat space going down, but they're hitting the barrier, and they're applying force to the barrier, and that's just rebounding back into them. So it's almost there's a vibration that happens when force is applied, and there's just this equal and opposite reaction that just keeps happening at a very high frequency when you're even just sitting down. There's your ass is vibrating, and there's this constant attempt to realize our inertia that we're not being allowed to realize. So we're sort of realizing it, but we're realizing it in little tiny bumps. So instead of actually going, we're just bumping our inertia, vibrating our inertia. So that's why the clocks, ironically, these go slower because of the speed of the satellites. So the satellites are moving and falling. So they have two speed coefficients, so two components of inertia, their directional speed and their gravitational inertia. So they have a component, say, of 10 velocities, okay? But the counter is this clock isn't at one velocity, it's at some other number. So it's at like 2 velocities because it has the inertia of the gravity itself. So depending on where this clock is, it will have more or less velocity. So the closer you get to the center of the Earth, the higher this V number would be, even if it's not moving. So if you could go halfway down to between you and the center of the Earth, you would gain, well, proportionally you'd gain 4 times as much. So you'd have 4 V of velocity, even though you're still not moving. Just from the pressure and the force you would be applying would be increased by that much. Something like that, anyway. I think that was pretty much correct. So there's a point where you could dig a hole deep enough where your clock would be the same as this clock, because you would have acquired so much velocity or inertia. Well, see, that's the trick. No, so I did do this wrong. No, that's right. So say it's 16 feet a second on the Earth's surface. That's the number for the Earth's surface. Is 16 feet a second is added. But as you go deeper, it becomes, like, this would be 64 feet a second. So the deeper you go, the further gravity takes you, the more feet a second you gain in acceleration. See, it depends on how they did that math. That 16 foot a second number might be the average from the surface to the center. It might be the average speed over the entire distance. So I'm not sure of that. It's obvious it would change with every foot you traveled. This number, the 16 number, would change otherwise. So they must have averaged it out. Well, I'm not sure of that. But it doesn't... In theory, you get my drift. But it is interesting that it's only momentum that creates this change in how matter ages. You know, this change in atomic metabolism. And you can gain this inertia, this effect, either from gravity that's acting on you, just going through you. Just the fact that gravity is affecting you gives you an element of inertia. If you're able to free fall, then you can gain more momentum. The momentum gets compounded because the inertia, the gravity becomes acceleration and not just inertia. So, but yeah, that's the effect. So you're getting, there's 2 ways you can get your 2 ways that your metabolism of your atoms get changed, and that is the effects of a gravitational field pushing you down, whether you're going down or not, and velocity in a direction. Okay. So I just thought that was, like I said, so my theory completely is consistent with all of this time dilation. It's not time that's being dilated. It's the amount of work the mechanisms of the atoms have to do that is changed, which changes the metabolism, how rapidly the school will be able to metabolize food that comes in, or energy that comes in, or anything that comes in. It won't be able to metabolize it as efficiently or quickly as it did before, and it will have the appearance of having slowed down. But again, matter can never approach any of these speeds. Remember, these are all just the elements of matter are elements all moving the speed of light. And if the matter moves the speed of light, that means all the fish have to be going the same way, which means you have no matter anymore. Matter is only circular, photons trapped in spirals. And once the photon is not in a spiral, once it's returned to being in a straight line, it's no longer matter, it is now E. Okay, it's M when it's in a circle, and it's E when it's a straight line. There's a simple postulate for you. But all motion is absolute, space is absolute, there is no relativistic effects, there are absolute effects, and the faster you move something, and it certainly is going to depend on what you're moving. If you're moving a very heavy, complex atom at a high speed, it's likely that atom will deteriorate and fall apart before it will start moving very slowly. So it will give off, it will lose its identity with enough momentum. And certainly momentum's, inertia's speeds anywhere near the speed of light. The integrity of the atom, the integrity of these spirals and the connections of these spirals is going to start breaking down, and the matter won't be able to be maintained, because there's just no way you can maintain the knot and move this swirly knot at a very high speed, because there's too much eating of space, and there just won't be any there won't be any structure left. The time will break it down. Yeah, so that's enough for this video. So yeah, Roberto guy, sorry, you're gonna lose this argument, and I'm gonna kill your little unicorn of multiversy, bibbly babbly boo fantasy physics. There's a reality here, and time travel isn't part of it, unless you're gonna call going to sleep time travel. Yes, theoretically you can move matter fast, slow down its metabolism, make it last longer, and return it, and it's going to have aged less. That's possible. So you can do the go to sleep and wake up in the future thing, but you can't do anything strictly called transporting in time. You have to do it the hard way. Which means you have to actually slow down your metabolism, and real time will pass. You'll just metabolize it slower. Yeah. Okay. Until next time. I think that's enough. I don't think I have anything else. I thought there was some other thing I had observed, but yeah, it's just like I said, every day some new thing occurs to me. I really have to start writing it down because I don't want to lose it all. But it's very interesting. I just wish there was better commentary than this. So anyway, until next time.